Hi everyone, what's up? Today I want to solve with you a pretty cool definite integral. So today we're going to go over the integral from 0 all the way up to pi of the function sine x dx, okay? So this is what we're going to solve today. The integral itself is pretty easy to solve, but I wanted to talk about the sine function. So this, remember, when we compute this integral, we're going to find the area under the area of, the area under one hump or one hill of sine, okay? So remember, the sine function is gonna look something like this. So it's gonna look okay? It's gonna be kind of like this. So remember, sine evaluated at 0 is gonna be 0, and sine, the roots of sine can be found at every pi, at every multiple of pi, okay? So 3 pi, 2 pi, 5 pi, 4 pi, you're gonna find the roots of sine right there, okay? So this area, what we're gonna find here, well, it's gonna be equal to this definite integral, okay? And that is what I wanna do today, okay? So let's find how much that is. So I'm gonna say here, a is equal to this. So let's see what we got. So what is the antiderivative of sine? Well, we know that it's gonna be minus cosine, because the derivative of cosine is gonna be minus sine, and you need another minus to get rid of the first minus. So we're gonna have, this is gonna be minus cosine of x, and we want to evaluate this function at 0 and at pi, okay? So we have minus cosine pi minus, be careful, because we have, remember the first fundamental theorem of calculus says that we want to subtract the entire function, the entire thing, the entire expression that you have here. That's what you want to subtract. And this function, well, it has a minus. So we're going to have minus the function, and that function begins with another minus. So you need to keep it there. So this is going to be minus cosine x. I'm sorry, not minus cosine x, minus cosine 0, okay? And now let's see how much we get. So another helpful trick to know the values of cosine, remember, so the roots of sine can be found at multiples of pi, and sine is going to have, I like to call it, the inverse properties of cosine, okay? So if you find the roots of sine at pi, then you will find the maximums, the highs and the lows of cosine at pi's, okay, at multiples of pi, okay? So for instance, at 0 pi, cosine is going to be 1, which is its maximum value, okay? And then at pi over 2, it's going to have a 0, okay? And then once again at pi, it's going to have a maximum, it's going to be negative 1, okay? So, if the roots of sine can be found at a particular number, at a particular set of numbers, which in this case are going to be the multiples of pi, then you can find the maximums and minimums of cosine at those same numbers, okay? So it's pretty much just everything is inverse with sine and cosine. So how can we know the value of cosine pi? Well, we know the value of sine pi is going to be 0, which means that cosine pi has got to be a 1 or a negative 1. We know cosine begins at 1, at positive 1. It begins up here and then it goes down. And we know a root of cosine is going to be at pi over 2, because a maximum of sine is going to be at pi over 2. This is pi over 2 and it's its maximum. So we have a 0 for cosine at pi over 2, which means that we get a minimum for cosine at pi, okay? Now that means that, well, this is going to be negative 1, okay? So we have, this is going to be minus 1. We have minus times the value of cosine pi, which is negative 1, minus, now the value of cosine 0 minus cosine 0, we know it's going to be negative 1, okay? Cosine 0 equals 1, so you get, this is just going to be plus 1. I'm going to write it like that, okay? So yeah, and now, well, this is great because you can see that we get a pretty definite and interesting number. This is going to be 2, okay? Let me write that 2 again. This is going to be 2, okay? That looks better. And this is equal to a, okay? Now, usually, I'm not sure about you, but I thought that, oh, damn. Oh, sorry, my marker just, fell to the ground. So, I usually, I used to think that sine and cosine were pretty, how should I put it, undefined functions. Usually, when you compute a value for sine and cosine, is going to be some long decimal. Usually you don't really deal with integers when you deal with sine and cosine, except, at their maximums and minimums and roots. So I thought that, the area under 1/2 of sine was gonna be some, some weird decimal, some weird fraction, but no, it turns out to be a very cool integer, too. So that's something cool, I think that was a surprise for me, and well, I think it's interesting. So I think that's been the entire video. Maybe another thing that I would like to say is that this area, so this area A is going to be the same area that we have here, okay? That is just going to be a signed area. Remember, if you've ever coded before, if you know some computer programming, remember that we have unsigned values and signed values, values that can have a sign, like a negative sign, or values that don't have a sign. So this A is going to represent the unsigned area, and this depending on, there might be some tricks with the negatives over here, but this can also be the signed area, okay? So you could get negative this amount, okay, which would still be an area, but yeah, that's something also, worth mentioning. So yeah, these two areas, this area is going to be the same as A, okay? So yeah, that's been the entire video. I hope that you enjoyed it, and see you in the following one. Bye.